Welcome back for lesson 3.5. We are now going to use another visual way to display probability data and outcomes. And that is called a tree and Venn diagram. There's going to be two diagrams that we're going to use. So the first is going to be the tree diagram. So a tree diagram is a special type of graph used to determine the outcomes of an experiment. It consists of branches that are related that are labeled with either frequencies or probabilities. And the branches have to do with the possible outcomes of the experiment. So our example says, in an urn, there are 11 balls. 3 balls are red and 8 balls are blue. And you can see that here in the first draw. So 8 are blue and 3 are red. Draw 2 balls one at a time with replacement. With replacement means that you put the first ball back in the urn before you select the second ball. So there's always 11 balls to choose from. The tree diagram using frequencies that show all the possible outcomes are. So on the first draw, I could get 8 blue balls or 3 red. And on the second draw, I could still get 8 blue balls and 3 red. And you can see that this is what would happen if I drew a blue ball on the first and a blue ball on the second, a blue ball in the first or a red on the second. And then over here is if I drew a red ball on the first and a blue on the second, or a red on the first and a red on the second. So the 4 possible outcomes are blue, 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 red, red, blue, and red, red. I'll kind of explain that down here. So there are a total of 11 balls in the urn. Draw 2 balls one at a time with replacement. So because there are 11 balls times 11 balls from the first draw to the second, there's actually 121 outcomes, the size of the sample space. And we're not going to draw all those 121 outcomes, but we're going to use the tree to help us find these probabilities. So it says list the 24 blue red outcomes. So it would be blue 1, red 1, blue 1, red 2, blue 1, red 3. And then it would go blue 2, the first red, blue 2, the second red, blue 2, the third red, all the way through the 8 blues. Let's go to our questions about the tree. So it says, using the tree diagram, calculate the probability of getting a red and a red. And a red and a red would be getting a red and then a red. There's 9 of those outcomes out of the 121. We're just going to leave these in fraction form. Using the tree diagram, calculate the probability of red, blue, or blue, red. They are mutually exclusive, and so we can just add them. Let's make a note. Because they are mutually exclusive. So red, blue, there are 24 of those. Plus the blue red, there are 24 of those. So there are 48 out of the 121. Using the tree diagram, calculate the probability of red on the first draw and blue on the second draw. So that would be probability of red and then blue. And that would be 24 out of 121. Using the tree diagram, calculate the probability of red on the second draw given blue on the first draw. Okay, so probability of red on second given blue on first. So that would be the probability of them together, which would be B and then R, blue in first, red in second. So the probability of BR divided by just getting the probability of the blue on the first. Okay, so the probability of the BR is 24 out of the 121. And then the probability of just getting blue on the first draw is 8 out of 11. Because that's just on the first draw. So this would be 24 over 121 times 11 over 8. And 8 goes into 24. 3 times and 11 goes into 21, 11 times. So 3 out of 11. Using the tree diagram, calculate the probability of blue and blue. And that is the 64 right here. Blue and blue is 64 out of 121. Using the tree diagram, calculate the probability of blue on the second draw given R on the first draw. Okay, so probability of blue on second given blue on second given red on first. Okay, so up here we did the formal way, but I want to show you how you can get the 3 out of 11. Up here when we said, what is the probability of getting red on the second given that you had blue on the first? So we could just go to the blue on the first and look and see out of the 11 on the second, 3 of them are going to be red. So we can do the similar down here using a tree diagram, just like we used the contingency table as well before in lesson 3.3, or sorry, in lesson 3.4. So given that we have red on the first, what is the probability of blue on the second? And that would just be 8 out of the 11. Let's try another one on our own. So in the standard deck of 52 cards, 12 cards are face cards, event F, and 40 cards are not face cards, event N. Draw 2 cards one at a time with replacement. All possible outcomes are shown in the tree diagram as frequencies. Using the tree diagram, calculate the probability of F and F. So we're really just talking about 2 events, F and N. And we're drawing 2 cards. So we're going to have 2 layers to the tree, just like we did on the last one. So we're going to have draw number 1, and that would be F and N, and F is 12 out of 52, and M is 40 out of 52. And notice that they add to make 52. And then the second is going to be the same. It's going to be 12 and 40 and 12 and 40. And this will be F and N and F and N. And so this would be face card, and this would be 12 out of 52 times 12 out of 52. And then this would be F and then N, so 12 out of 52 times 40 out of 52. And then this would be and then F, and that would be the 40 out of 52 times the 12 out of 52. And then this would be N and N. So 40 out of 52 and 40 out of 52. Okay, and our sample size is, we have 52 times 52 because we have an independent situation because we said it was with replacement. Okay, because it's with replacement, they're independent. So for our sample size, we can just do 52 times 52. So there are 2,704 outcomes in our sample size. And we're going to use these to help us answer some questions. Okay. Now, in the next one, we're going to set up a little bit differently. It says, in a standard deck, there are 52 cards. 12 are face and 40 are not. But this time, it's without replacement. So notice that the tree starts off the same as our one that we just made. But the second draw, there's only 51 cards because they're doing it without replacement. So it's not independent. So that means that there's only 51 cards available. And if you drew a face on the first one, then there's only 11 face available and there's still 40 not face cards. If you drew a non-face card on the first draw, there's still 12 face cards and there's only 39 non-face. So it's asking us to find the probability of face and then no face, or no face and then face. So face and then no face would be this right here, 480 over 2652 plus 480 over 2652. Now remember, you're adding common denominators, so the denominator stays the same on your fraction. And we have 960. Which would be 36.2%. Find the probability of n given f. So given that we had a face on the first one, which would be over here, right? What is the probability of getting an n on a non-face card on the second? Well, it's a little bit higher because there's still 40 of them, but there's only 51 cards. So that would be the 40 out of 51, which would be 78.4%. Now, had we done with replacement, it would have been 40 out of the 52. So it would have been about 76.9%. So this definitely increased it a little bit. Find the probability that at most one face card. Hint, at most one face card means 0 or 1 face card. So at most one face card. So it can't be this one because that's got 2 face cards. So it would have to be the 480 plus the 480 plus the 1560 when there's no face cards out of the 2652. So that would be 2520 out of 2652. About 95%. Find the probability at least one face card. Hint, at least one face card means 1 or 2 face cards. Okay, so at least one face card would be the 132 plus the 480 plus the 480. This time we're excluding the no face cards. So 92. could be 1.2%. Okay. Good job. Next up, suppose there are 4 red balls and 3 yellow balls in a box. 2 balls are drawn from the box without replacement. Okay, so let's draw our picture first. So we've got draw 1 could be 4 red or 3 yellow, 4 red or 3 yellow. Without replacement. Okay, so we've got draw 2. So draw 2, if I drew red on the first one, I've only got 3 red left, and this is 4 out of 7, right? 4 out of 7, and this was 3 out of 7. But now there's only 6, because without replacement, we now only have 6 balls. So we have 3 out of 6 are the red, but we still have 3 out of the 6 that are yellow. Then over here, had I drawn yellow first, I would still have the 4 red out of the 6, but I would only have 2 of the 6 that would be yellow. So let's go to their question. So let's just write this down. This would be red and red. This would be red and then yellow. This would be yellow and then red. And this would be yellow and yellow. What is the probability that 1 ball of each color is selected? So that would be here and here. So this one, so red, yellow is 4/7 times 3/6 plus the yellow red is 3/7 times 4/6. That is 12/42 plus 12/42. Adding common denominators, so we only add the numerator 24/42. So that comes out to be about 57.1%. Great job. So that is tree diagrams. So this ends the part 1 of lesson 3.5. Catch me back for the second part, and we're going to learn how to draw Venn diagrams that are using circles.